The original Metroid came out in the late 80s on the Nintendo system. This is one of the levels called Ridley's Hideout. As you can see, we have a map. In this part is a scrolling section that leads you into a starting room. We then scroll a bit further and we move into a flip screen game, which has got a sliding transition. What we're going to do is try and recreate this map and the navigation system and the transitions in the next 15 minutes. So in the link below, you'll be taken to this website, which is where you can download the template system, and you just visit the download option and download the zip, or you can clone it. Full documentation is provided, and also how to recreate the whole of Metroid, which is what we're doing in this video, is listed here. The other way to do it is when you start Godot, go to the templates and you should find it by searching for flip screen. All you need to do is check the version is the latest one, and when you download it and install it, it will just create a project with the basic files. So if we open up the project, it comes supplied with a sample game called Cybernoid, which was on the ZX Spectrum in the late 80s. So if we run the game, the first few screens highlight some of the features. So as you can see, we have a HUD across the top, and that is optional. That remains static. And we have the first screen, which moves into a sliding transition. We have the next one, which is a fading transition. And now we're moving into a scrolling area, and then onto a basic flip. When we go right from this screen, we will enter a warp area. In other words, we will jump from this room across 4 or 5 screens. This can be coded through a pickup or a simple transition. And in this case, we will be using a slide transition. We can also do a fade or a basic flip. And that is what the template system comprises. What we need to do first is we need a tile map. Obviously, you might create your own, but if we go to this website, NES Maps, and here we have a level called Ridley's Hideout, which is one of the mini bosses, and we will be recreating that map. So as you can see, this is the map, and across here is where we entered the game. So I have tools that I created that converts images like this into Godot tile maps. Let me know if you would like a video on that. If we open up Metroid and select it, you'll see it is a tile map. There's nothing else in it, just the tiles with some collision shapes preset. The only requirement for the template system is that you put your tile maps into a node. Now, you can have as many tile maps as you want if they are layers, or you can even add any other node you want. It doesn't matter. These might be your enemies. All that's needed is a top level node with a tile map. If you look at the Cybernoid, we have 2 maps, and we use one of them for the foreground and the other for the background. If we go to the game node, this is the starting point for your game, and if you already have your own game, then you would copy the room manager, the cameras, and the map into your own game. And there's a little bit of startup code in game that you would copy across. This player object is simply the spaceship that we used in Cybernoid, and we will just reusing this for Metroid for simplicity. In this map, we have a number of screens, and I know that they are 512 by 480. So if we set the snap grid to 512 by 480 and then view the grid, we can sort of see every room now. When you're setting up the room manager needs to know where every room is, and its default mode is a sequential number starting from 0 in the top left, going across and down. So as an example, if we go to the website, you can see here we have 17 rooms across, and the game needs to know how many these are so it can work out room numbers going downwards. You don't have to stick to this number. In this case, we are rounding it up to 20, and that makes it easy to upgrade every number. So it doesn't matter that room 17 doesn't exist because we will never reference it in the game. But what we can see is no matter where you are, the row up and down is always 20 plus or minus. The starting room in Metroid is 11. If we go into the map node, then this here is our tile map. So if we delete that node and we instance the Metroid map, we'll call it Ridley, and as you can see when we go into it, it is just our tile map. And like we said, the only requirement is this has to be a node which then contains at least one tile map. If we select the map node, we get some custom properties, and where we need to specify that size that we mentioned. So we needed 20, and we need the start room in case we want to start on the default start room, which you normally will. And just for an example case, we will put 0 so we can see that this screen here is visible on the screen. And we'll go into the project settings, into the window, and change the window to be the correct size. We're also using the test width and height just to double it to make it easier to see and a little bit larger. If you notice, it uses by default a viewport and keep aspect ratio, and it also has pixel snap turned on. You can change those, of course, if you want. Now, if we go up to the run option, by default it will run the game with a HUD, so we will specify instead game. So if we now run the game, we should get this start screen and it should fill the screen, so we know everything is set up. In the template system, Room Manager is the main node, and it does all of the orchestration and management of the rooms. It talks to the camera and the map. Cameras contains the flip screen and the scroller, and they know nothing about any other part of the system other than how to move themselves. And in the same way, map only knows about itself, and it only knows how to display its map and provide data on itself, such as sizes. So everything goes through the room manager. So most of the things can be configured through the export variables. So if we select room manager, the first property we have is default transition. In other words, when we move from one screen to the next, how do you want to transition? And in the template system, there are just 3 at the minute. None, which just goes straight to the page. Slide, which is, as you've seen, slides across. And fade. And also the default transition time is how long it will take for either a slide or a fade. We will just leave it like this for now. When we go to map, as you've seen, we've set this to 20, and we've also set the start room to 11 now, so we are in the right place. If we go to the cameras, then the only thing that we need to update is this property called room navigation pixel offset. And what that basically means is how far off this screen edge does the player have to go before a room change event is triggered. Our spaceship is 32 pixels, so we'll leave it halfway. So once the player goes halfway past the screen, then we will trigger that. Okay. Camera scroller has no particular properties. What it does is it reuses the drag margin and the limit section, and that is how it creates scrolling areas. All of the other properties you can update yourselves. So for example, I've set the drag margin to be 0.4, and this drag margin is basically how far from the center of the screen the item that is controlling the camera needs to move before scrolling starts. This item here called background is just a canvas layer with a black rectangle. What it's used for is if you have a game without a background. As you can see, we have a transparent background, but when we run the game, if we use this game background node, then it will make every screen whatever color we've set. In this case, it is black. We can see our player, and what we'll do first is to change its Z order to be 1, so it's above the black background. And we will then move it to the start place on room 11. What we need to do now is tell the game where to move and what rooms are allowed. So in the start room we can go down but not left or right, and we may want to, in the next room down, we may want to block upwards movement. So that is done currently through the map system. So this is where we inserted our map. So every level that you create, you will want to either remove your map here. So for example, remove from the scene this Ridley map and then add our own, or you might just want to duplicate this entire structure for every map. If we go into the code, then we have a dictionary of room navigations. So what we're seeing here is every room has a number, and our start room in our case is 11, but obviously this is Cybernoid, and we specify where they can move in the direction of up, down, left and right. So every time we see an array, it always represents up, down, left and right. So in room 0, you can move down to room 10. -1 means nothing. If you have a transition entry, then the entry here corresponds to a transition that you saw in that drop down. So 0 is none, 1 is slide and 2 is fade. And when you add your own, you can just update the number. And the second parameter is the duration to take when transitioning. The other options is exit positions. So when you move from one screen to another one far away, we need to tell the system where to position the player in that non-adjacent room, and that is what this does. So in this example, when we move down to 23, then we want to position the player at pixel location 160 by 200, obviously, and this is relative to each screen. So 0, 0 is always the top left of whatever map you have. So if we replace that, then we have room 11, which we start, where you can go down to 51, etc. So if we run the game now, we have no collisions on the tile, but we can move down. As you can see, we're moving down. We can't go left because there was no navigation set. So let's add a few basic navigations. And we're going to add scrolling in a little bit. So what we'll do first is we will replace 51 with a transition of slide. And that is basically, when we look at the map, when Samus entered the room and got to here, then it scrolled across to enter this room. And what we'll also do is, just to show you working, we will add a warp from this room here, which is room 51, and we'll go all the way across to the end, and we'll add a slide. Show you what we've done. So in room 51, we've said you can go up to 31, left to 50 and right to 55. When you go left, it will do the slide and take half a second, and when you go right, it will do a slide and take 2.5 seconds, and it will then position the player at position 160 by 200 on room 55. here. Before we proceed, we'll just set some collisions up so we can navigate the map a little bit better. So if we look at the player, we have set up collisions to say that the player is on bit 0 and he collides with or look towards bit 1, which we've called environment. If we go to our map in Ridley and go to the tile map, we will set the layer to be on environment and its collision on the player. We've already set up, or I've already set up, the tile map for collisions. But we'll just add one more on this dot here. What we can also do, because we've now removed Cybernoid completely, we can just remove those two scenes because we do not need them. If we didn't want that background, then we could delete that from the scene as well, and we could also go to the scenes folder and remove that scene. Now if we run the game, we should have full collision. If you go left here, we should get the scroll effect. And if you go right, it is just using the default because we didn't set anything up. And now if you go right, we should slide all the way across to room 55 and land at 200 by 160. Now we will add some scrolling. So as you remember in Metroid, we started on room 11 and we scrolled down. What we'll also do is add some scrolling for this entire vertical shaft. When we are in the map, there is a section called scrolling regions. Here we have a single shape, and what we'll do is we'll just move it across. In fact, we will set the snap up. So there we go. There. So we'll scroll down to room 2 and then it'll turn back to normal. If we then duplicate that node, we need to make it unique so that we do not end up resizing them both. This is room 55, and then we want to go right into 56 and add 55 and 56. So 55 will go right into 56, and 56 at the minute doesn't do anything. And the reason why we're doing that is because in order to move into a room from 55, this room 56 has to exist. Now this data array for the room manager and the camera system is only really used by the flip screen. So there's no need to define all of the rooms in between. So if we run the game now, and we'll just go straight to the scrolling, as you can see, we then stopped and then we move into a flip. So we'll get our fast transition across to the warp area, and then we will go, if I move the mouse, if we go right, we've now entered this vertical shaft, which is now a large scrolling area. And that really is all there is to it. What we'll do now is add a HUD. We will reuse the HUD that was part of the Cybernoid demo. It is a basic node inside of a canvas layer. Remember, canvas layers are always fixed to the screen. They never move, and we have a GUI component containing our HUD. And it is 512 across and 64 down. So what we need to do is go into our window size, and we need to add 64 to our height because we want the entire screen to fit that. In the run mode, we change it to game with HUD. If we open up Game with HUD, what you'll see is it is a node containing our game as an instance. So if you notice that there is nothing else in this other than a few control nodes, so it doesn't matter whether you have a HUD or not, your game remains exactly the same. The way it works is we have our UI element, which we've just seen, which is in a canvas layer, so it will always appear at the top of the screen, and then we create what is called a viewport, and a viewport is a sub-view to the screen, and it is set up so that it will work as long as we tell it some basic sizes. So if we click on Game with HUD and we go to the section here and say Use Override Settings, we specify the size of our game itself. So in other words, it is the same as the game before the HUD, which is 512 by 480, and we need to tell it where we want to start the container. So we want to start at after this HUD, which is 64 down, which is what you can see here. It's not reflected in the screen because for two reasons. One is it is a viewport and Godot doesn't show viewports very well. And secondly, we are just setting them in properties so the GUI is not updated. However, if we run our game now, as you can see, we have exactly the same game, but we have a HUD. If this basic layout is no good, then what you can do is undo the override settings, and then you can manually size it yourself. So the equivalent of what we've just done here is the same as going into viewport and setting its size to be 512 by 480, and then going into the viewport container because it doesn't update itself, and setting its its size to be 480 as well, and then we set its offset to be 64. Now this will work exactly the same, and the other advantage is we can kind of see what we are getting in the game. So let's have a look at a bit of the code. In Game with HUD, when we look at the code, all we are doing is getting a reference to our game object, and we tell it to configure itself, and we pass across the size of the viewport, in other words, the 512 by 480. If you are just using these as components to your game, then you will need to recreate this bit of code. So if we go into game, the game code is very simple as well, and it calls its configure game the same as we did with the HUD, and in configure game we tell the room manager to change rooms to the default room, which is the value that we specified in the map, which was room 11. How it gets access to room changes and the player movement is through signals. So when the player changes screens, it calls this event, and our default code is simply to ask the room manager change rooms based on a direction, which is left, right, up or down, and it will then use this array to first of all work out if it can move and then use the transition. If you recall, when we did the warp, we also moved the player. Now we have no reference to this player in the room manager or any of our nodes. If we then look at the room manager, it sends a signal called room manager map reposition player. So if we go to our game code, which of course could be your game code, we have overridden these signals, and in reposition we just update our player node. So the signal from the room manager for reposition passes back those coordinates that we specified, but as a global position. The other two events that get triggered is the scrolling system, which sends a signal when it enters and exits a scroll region, and the default is to call Room Manager and ask it to change into flip mode or camera scrolling mode. The last thing you might be interested in is how the scroll camera works. So if you notice, we have a scroll here, but the way we would get it to work is the camera for scrolling would have to be inside of the player node, in other words here. So what we do instead is we can keep this basic node structure for the template, but I have added a remote transform to the player, and in the remote transform we've specified the camera as the camera scroller as the remote path. There are various other methods you can use, but they are documented at the website, and we'll not do it here. We'll not go into detail here, but the flip screen camera is comprised of two things. This green box is the size of the current screen, in this case 512 by 480, and it's a static body, and it blocks the user or the player on either of the four directions, or allows them through. And this outer line is what triggers that 16 pixel offset to change rooms. So in other words, if we are allowed to move right, then this line here is disabled. The player moves across to this box and triggers the event.